Hello and welcome back. And in this video, we are going to be looking at our coin service. So let's go ahead and get started. I'm going to create a new file here. We're going to call this one. It's going to be a Swift file. So just select Swift template. And we're going to call this one coin service, like so. Okay. So what we're going to do is we are going to be using this API. Let me pull it up really quickly, and I'll show you what we have. Okay. All right. So this is going to be the API. We're going to use coinranking.com's API. So if you go on coinrankings.com, you're going to find their API link, or I'll just put it in the source code so that you can have it. I mean, it's going to be there in the source code anyways. So basically what this does is it gives you access to this public data about coins, and based on their symbols, and a period of time, like you can request. So you can request 24 hours, 7 days, I think 14 days or stuff like that, or 28 days, something like that. There is another number, but I don't clearly remember that. Their API documentation explains that. So if you wanna use that as a reference, please feel free to do that. Okay, so let me show you how the data response looks like. So you have a dictionary as a JSON response, and that has status as one of the key, and another key is data. So if you notice, data has a whole bunch of other stuff. So we are interested in that part, and stats is basically talks about how many total number of currencies there are, or how many total number of records, basically in this case. And there's any offset. So basically if you're using paging, then it tells you that there is an offset. Base is basically the base price set that's for this currency. So the amount that's shown here, is based on US dollar. So we have requested that by specifying base is equal to USD right here. So that's why base is USD that's being returned. So that actually validates that our amount is currently reflected in the API. And then you have total market, total exchange, and stuff like that. You have a base dictionary that has in the JSON response, where you have symbol as USD and sign as dollar if you want to use this, or you can use number formatters currency for locale based on the area that you're requesting currency on. Okay. By the way, if you want to find out what other currencies are supported, please feel free to check out the documentation as well. It has it listed very well. So I'm not going to go waste our time looking into the documentation. So let's keep this series focused on the API response itself. Okay. So next thing we get is coins. That is the main data that we are interested in. And if you collapse all these, you're going to notice that we get 8 coins that we have requested. So there are 8 coins, and we have requested Bitcoin, Ethereum, USDT, I think is Tether or something. Not really sure of, but yeah. What you get as a coin response is basically their ID, their UID. There's slug, symbol, and name and description. If you want to use that, you can even build out this project to show when a user taps on a currency, you show them the detail 7-day progress, and basically high and low, along with the descriptions what that currency is. You get icon, the color of the currency icon, in the icon URL as well. Although what I did is basically I downloaded these icons in PNG format instead of making another network call. And if for your cryptocurrency you're gonna stick to a standard set, I would actually recommend packaging some assets with your app, because that actually takes away the burden of like re-downloading it, and it's actually good for your users, so it keeps their network usage in check. Okay. Anyways, you have socials. For the social links, there are links about the currency itself, and then you have number of market, number of exchange, type is a coin, and basically there's volume, market cap, price is one thing that we're going to be interested in, because we're going to be showing that right there like that. And there's going to be circulating supply, total supply, and change. So change it has seen since the last request. That's going to be this one that we're going to show. So that's going to be there, and then you have history right there. Okay, so 7-day history that's been reflected here. I believe it's 7 days. It looks more than 7 days though. I don't know, like I didn't check really, like for the history, because I just wanted to see how the graphs in the graph control works. So please check the documentation, see, like probably they talk about how the history is distributed. Okay. There's a ranking listed there, and you have like all-time high stuff listed as there as well, although we don't use that data here, but if you want to use it, you can use that. All right, so that's our API that we're going to be using. So I'm going to copy this, and what I'm going to do is I'm going to paste it right here, so we know which API link we are using. And we can create API response two ways. We can use URL components to do that, or we can simply paste the URL from the string and construct that. So let me show you both ways. First, we're going to import combine. Okay, and then let's create our class. So this is going to be a final class, because we are not going to need this to be inherited or anything. So, and that actually helps compiler. If you have like final class, and compiler knows that there's no dynamic checking, like for inheritance and stuff, encapsulation stuff is going on there, so it's actually optimizes your API, your app class during the compilation. Okay. Next, we can, like I said, we can create two ways for your URL. One is you can create, let's say, URL, and you can have like URL with string, and then you can paste that string, and that actually will give you a URL representation or URL object of this string. Okay, so I'm going to comment this one, because we're going to be using URL component just to show you something different this time. And before that, let's create a symbols array, so we can track all the symbols that we are actually using. So I'm gonna copy and paste this static data. All I have done is basically taken this part right here and put it in an array. Okay, so that is our symbols. Then we're gonna create lazy var property for URL components. All right, and this is going to be component, a local variable of type URL component. We're going to reinitialize it here. Component.scheme is going to be HTTPS. Component.host is going to be this part right here. So we're going to simply copy that and paste it. Component.path is going to be, now remember this backslash, don't forget that, and copy it till coins. All right, then you have component.query items, and query items is an array of query items, so URL query items, and that takes two values, name, so we're gonna say base is gonna be USD, Then you're going to have another query item, and once again it's going to take two things. So we're going to say second item is time period, so it's this guy right here, and the value for this is going to be 7D. Okay, next up is query item, and this one is going to be symbols. And here what we can do is we can simply say symbols dot join or joined, and we're going to say separator is going to be comma. Okay, and this right here is our whole URL string. So let me put them on their own individual lines so it's easy to read, and we're going to return component. Okay, so this actually returns a URL component which we can use. Okay, let me put the brackets so it's executing. So what this says is basically this is a closure, and what it does is basically whenever this this particular variable is called, it's not loaded. It's not going to be called when the class is loaded into memory, but it's when it is called or when it's actually being utilized. That's when we are going to basically initialize this, and it's going to be initialized only once, and then after that it's going to be available for rest of the calls to be used. So it's rather like, you know, memory efficient way of creating your variables, or like, you know, these kind of objects. Okay, so next up is we're gonna need some model classes, so we can actually create them right here because they are sort of related to coin response, and then we'll move them into their own file. Okay, so we're gonna create struct coin response, and this is going to be decodable, so this is going to be decodable like that. Okay, and this is going to be basically those two objects that we get first at the first hierarchy level, status and data. Now data is basically a collection of coin data, so let's create a struct for coin data. This is going to be decodable as well, and we're going to say this has coins and it needs something as well. And this needs something, and this something is coin data like that. So this needs something, so let's go ahead and create that something down below as well, and then we're going to copy them into its own file. So coin decodable, and this is basically our main coin, the properties that we need to be parsed from the API. So we're gonna need price, history is returned as an array of string. So we have name, price, symbol, color, change as double, and history as array of string, and that is going to be the part right here. So array of coin. All right, so let's go ahead and move them into their own respective files. So we're going to create this coin response file first in the model, and Swift file coin response, and let's go back, and I'm gonna cut this. There you go. Okay, let's create another one, and this one is going to be called coin data. Now in our case the classes are really small because the response that we are dealing with is very is very straightforward, but in your case it might be big, so that's why you might want to create a separate class. Okay, so next up is coin itself, so I'm going to simply cut this guy and just say new file coin, and just gonna paste that in here. Okay, remove extra lines, and there we go. Okay, let's go back to our coin service. Now what we're gonna do is in our coin service we're gonna get the data, and you're gonna see how easy it has become to use Combine for basically downloading data from internet. So I'm going to create function get coins. It's going to return any publisher of type coin response and error if there are any, and this is going to be an optional. Then we're going to simply first check guard let URL is equal to, now let's say URL components, so we're going to try to get URL from URL components. If we can't get it, then we simply return nil here. Okay. Next up, we can print URL if you want to see what the URL is going to be. It's going to look like, and we are simply going to return URL session dot shared dot data task, but this time we're not going to choose the data task with URL or anything like that. We're going to choose publisher. So data task publisher is what we're looking for URL that we have. Now this publisher returns another publisher that we can actually use to map the data. So we're gonna say map whatever is at the first parameter, its data part. Okay. Next up, we're going to use another filter to decode. Okay, and what are we decoding? Well, we are decoding coin response.self. It's your plain old decodable JSON decodable thing, and the decoder we're going to use is JSON decoder. Okay, so what you do is you give URL to your data task publisher, you map the response. So I don't know, Swift has, our compiler has been like, a little bit finicky about what kind of response, but it gives you three objects like data response. So in the response, it gives you data response, response data and error in your usual data task case. So let's see if we can jump into definition and get more information. It returns a publisher that wraps the data task for the URL request, right? And where's the response for the publisher? There's a response publisher that actually it's data task publisher receives. Okay. Okay, so let me show you actually. Oh, there we go. Output, data and response. So these are the two things that actually it returns, data and response. So what we are interested in, data, right? So we are going to take that data, we're going to decode that data, and we're going to receive it on. So you can actually specify which thread you want to receive it on. So you can say like main thread or run loop.main, like that. And you can even say dispatch queue.main. And now you're gonna say erase to any publisher. So basically your calling party or your user for this API does not know what kind of publisher it is. So it's just gonna say it's any publisher. It's just not gonna reveal the implementation detail for the publisher. Now this topic is mainly covered in another upcoming series for Combine framework that I'm actually currently working on. So stay tuned for that one, and that's going to actually explain you step by step like what any to erase to any publisher is. Okay, but let's keep this this one focused for this CoinTracker. All right, so you erase to any publisher, right? It's going to basically create another publisher, any publisher type, and it's going to return that any publisher type. Okay, so this is how, and this is it, like, this is how you actually get your data downloaded from the internet. All right, and that's it. We have all the code that was needed for basically our service is complete. So as you can see, like, it's rather like easier. It's become like rather easier using combined way of calling APIs, because you don't have to like have any callbacks and stuff like that, and it's simple task of filtering down different publishers with different set of operators. Basically these are called operators: map, decode, and receive, and all these things, a different set of operators to basically achieve your result that you're trying to achieve. Okay. So in the next video, what we're gonna do is we're gonna start developing our model. We've already done that, so that's good. So we're gonna do view models, and we're gonna do views and controls along with that, controls and extensions, to basically get this app going. Okay. So I'll see you guys in next video. Thank you.